Lesson 5-2, Estimating Sums and Differences, and in this lesson you learn to estimate sums and differences of decimals and fractions. Why is it important? Estimating with decimals will help you determine whether you have enough money to purchase the items you want from a store. Let's take a look at this example in business. The exercise craze of the 1980s changed the world of fitness and the world of fashion. Once seen only in the locker room, athletic shoes are now part of everyday wardrobe. The graph at the right shows the athletic shoe sales made to women, men, and children. What were the total sales of athletic shoes? Okay, so before we answer that question, in were the total sales of athletic shoes, let's learn the concept, and we will use estimation. So estimation is often used to provide a quick way to an easy answer when a precise answer is not necessary. So when you're not looking for an exact answer, estimation is the best way to go. It is also an excellent way to quickly see if your answer is reasonable or not. So later on, once we start getting the exact answers, we need to estimate first. So to find out if our answer is reasonable or not. So, to solve the problem about the shoe sales, you can use rounding to estimate the answer. Round each number to a convenient place value position. When you say convenient, that means it's easy for you to do in your head, something like that. Often the greatest place value position is used, then complete the operation. Okay, so when you're rounding, often than not, the greatest place value position is used. Okay, so to find the total sales, round each of the figures to the greatest place value that they all share, and then add. So you have the numbers 153.2, 115.9, and 96. This is coming from the graph right there. Okay, and you want to find out the greatest place value they all share, and in this case the greatest place value they all share is the tens place right there. So we rounded to the tens place. So 153.2 is rounded to 150, 115.9 rounded to 120, and 96 rounded to 100. Okay, so they share the greatest place value position. In this case, they share the tens place right there, and that's where we round it. That's where we round the numbers. Okay, so we add 150, 120, and 100, and it ends up at 370. So approximately 370 million pairs of athletic shoes were sold. Okay, so let's move on to example number 1 and see how this works. Estimate using rounding 8.890 plus 15.98. We want to round it to the greatest place value position that they both share. In this case, that is the ones place. So we want to round it to the ones place. So now we have 8.890 plus 15.98 is rounded to 9 plus 16, because we're rounding to the ones place, the greatest place value position that they both share. Okay, so the estimate answer is about 25. Okay, so in letter B, 132.62 minus 45.81, we want to round it to the greatest place value position both numbers share. So in this case, the greatest value position is the tens place, so we rounded to the tens place for both numbers. So this becomes 132 minus 0.62 minus 45.81. 132.62 rounds to 130, and 45.81 rounds to 50, because that is the greatest place value position both of these numbers share, which is the tens place. Okay, so the answer is about 80. When you subtract those two numbers, the answer would be about 80. Okay, before you use a calculator to compute your answer, it is a good idea to estimate the answer. This helps make sure that you enter the numbers correctly. So estimation can more or less tell you if when you're using the calculator, or you're using pencil and paper, if your exact answer is reasonable or not by comparing it to the estimate. Let's take a look at example number 2. Suppose you go to Miller Cycles to buy equipment for inline skating. You purchase a helmet for $29.89, a set of elbow pads for $19.26, knee pads for $21.67, and energy bars for $6.03. The cashier tells you that the total is $82.88. Is this a reasonable cost? Suppose you don't have you don't have a calculator, you don't have pencil and paper, so you need to estimate. So what do you do? Round each item to the nearest dollar amount, okay? Because in this case, the greatest place value all of these numbers share is the ones place. So you notice they all share the ones place, okay? It can't be the tens place because $6.03 does not have a tens place. So it is, we stay with the ones place, rounded to the nearest dollar. That is the greatest place value position, again, that they all share. Okay, so when we do that, we have now the numbers, the price is 29.89, 19.26, 21.67, and $6.03. Okay, we round them to 29.89 rounds to $30 to the nearest tens. Okay, nearest ones. 19.26 rounds to $19, $21.67 rounds to $22, and $6.03 rounds to 77. Sorry, $6.03 rounds to 6. Okay, add them all up, we get the sum of 77. Okay, so in this case, obviously the amount charged is not correct. Probably the cashier accidentally charged you twice for the energy bars. The correct total is $76.85, which is very close to the estimate. Okay, so by just using estimation, you can already tell that the cashier probably made a mistake, okay, in his total. Okay, so that's one way of doing it. You can estimate sums and differences of fractions and mixed numbers by rounding also. So in another rule for estimating, remember in the first rule, we round them to the greatest place value position all the numbers share. In this rule, when you're doing fractions, this is the rule that we need to follow. Okay, to estimate the sum and differences of mixed numbers. So we're talking about mixed numbers. Okay, round each mixed number to the nearest whole number. So when you're talking about mixed numbers, we need to round it to the nearest whole number. And if we're talking about to estimate the sum and difference of proper fractions, round each fraction to 0, 1/2, or 1. Remember what a proper fraction is. A proper fraction is when your numerator is smaller than your denominator. Of course, you know what an improper fraction is. An improper fraction is when the numerator is greater than the denominator. So, conversely, proper fractions are fractions wherein your numerator is less than your denominator. So 3/4 is a good example of a proper fraction. So if you're finding the sum or difference of proper fractions, you need to round it to either 0, 1/2, or 1. Okay? Let's take a look at example number 3. Estimate each sum or difference. In this case, you are being asked to add 4 and 1/2. Okay? Sorry, to find the sum, estimate the sum of 4 and 1/2 plus 16 and 19 over 32. Okay, so we need to round each of these. Since they are fractions, we need to round to the nearest ones place, okay, or to the nearest whole number in this case. So 4 and 1/2 plus 16 and 19 over 32. We round this to 4 plus 17, which will bring us 21. Why do we know it's 4? Because in this case now, your fraction 1 over 12 okay, is either rounded to 1 or to 0, okay, because you're rounding to the nearest whole number. But if we look at this one closely, okay, and let's say let's not make a number line, just let's just make a line. Okay, so if I make a line right there, okay, and in the number 1 I put 12 over 12, and 0 I put 0 over 12, definitely 1/2 of that would be 6 over 12. So if you look at 1 over 12, 1 over 12 is right here, okay, and it's closer to 0, therefore this becomes 4 and 1 12 is estimated to become 4 plus 0, because now you're rounding 1/2 to 0, and that's why it's just 4. 16 over 32 is rounded to 17. Why? Because again, okay, we want to find out where to round 19 over 32, okay, whether it rounds to 1 or it rounds to 0. If we create a line, same way as we did with 1 over 12, okay, so a fraction that is equivalent to 1 that has a denominator of 32 would be obviously 32 over 32. And a fraction that is equivalent to 0 that has a denominator of 32 would be 0 over 32. And halfway would be 16 over 32. And if you notice, 19 over 32 is right around this area right here. Therefore, it's closer to this number, which is 1, and that is 0. So therefore, we round 19 over 32 to 1, and that's the reason why this becomes 17. Okay? Because now 16 and 19 over 32 is approximately equal to 16 plus 1, because 19 over 32 rounds to 1, and that's how you got 17. Okay, long explanation for a short answer. So 4 plus 17 will give you 21. Let's take a look at the next example. In the next example, you have proper fractions, 7/8 plus 7 over 16, and we're just looking for the estimate. And since they are fractions, from what we've discussed, if you're talking about fractions, proper fractions, we need to round the fractions to 0, 1/2, or 1. So we go back here to letter B, okay, and let's analyze 7 over 8. So if we analyze 7 over 8, okay, and we make the same number line, now we just don't round, sorry, let me take that arrow out. Now we just don't round from 0 to 1, we need to put 1/2 as well. 0 and 1, because it's saying round to the nearest 0, 1/2, or 1. Okay, so in 1, okay, let me put that on top so it'll be uniform. We put all of them on top, just like our line for example A. This is 1, 1/2, and 0. An equivalent fraction of 1 that is a denominator of 8 obviously would be 8 over 8. 1/2 would be 4 over 8. And the 0 would be 0 over 8. And if we find where 7/8 is, according to our line right here, according to our segment, 7/8 is right around here. Okay, so 7/8 is here. That means it's closer to 1 than 1/2. Okay, so therefore 7/8 rounds to 1/2. Okay, right here. Sorry, rounds to 1 because it's closer to 1. And 7 over 16 rounds to 1/2. Why is that? Because again, if you draw the segment, okay, and this is 16 over 16, which is again 1, and we put 8 over 16 as our half, 1/2, and we put 0 over 16 as our 0. If we look at 7 over 16, 7 over 16 is right around here, which is close to 1/2, and that's why it rounds to 1/2. So 7/8 plus 7 over 16 is 1 and 1/2, approximately. Okay. Let's take a look at example C. Okay, our last example. We have 4/5 minus 3/8. Okay, and we draw the same line. So we have 4/5. You know that in 4/5. Okay, the middle number. The easier way to look at this is this. Okay, so look at your denominator and see what's half of your denominator is. Half of the denominator 5 is around 2.5, and you have the number 4. So you ask yourself, is 4 closer to 2.5 or is it closer to 5? Okay, because 5 over 5 is rounds to 1 and 2.5 over 5 rounds to 1/2. Okay, so in this case 4/5 is closer, or sorry, 4 is closer to 5, so 4/5 rounds to 1. And let's take a look at 3/8. Okay, 3/8, half of 8 is 4. That means 4 over 8 will give you 1/2. And since 3 is closer to 4 than it is to 0, 3/8 rounds to 1/2. So you now have 4/5, which is 1, okay, minus 1/2, where 3/8 rounds to. And the answer is 1/2. Okay? And that's how you use rounding, okay, to be able to estimate answers. Okay? And that's the end of our lesson. Thanks for watching.